All right, so remember with the set builder notation, the set builder notation starts off with that brace. And then we always start with what letter? X. And then we make that vertical line, which means such that. Again, that's just the way set builder notation is set up. And then our interval notation is saying it's going from -5, including -5, to infinity. So when we write that with inequalities, our x is in the middle. Our smallest number always goes in the front. So we can say -5. Since it is a bracket, we want to put the equal to, and then the infinity, and then we close our curly bracket. The other way you could do this, if you wanted to, x such that, and then you're saying that x is every number larger than -5, so you could just also write x is greater than or equal to -5. That would also be acceptable. Okay, you don't need both, just one of those would work. Either one of those would work. All right, and then the other part we did was taking the unions and intersects and putting them with the interval notation. So when you're trying to find, in this case, this would be the intersect of those two intervals. Again, it is going to be easiest if you make a number line. So the first interval, it goes from -4 to 0. There would be open dots on both of those. Our second interval goes from -2 to +1, and there would be closed dots on both of those. So the intersect, remember, has to include both where it's overlapping. So where do we have the blue and the green? The blue and the green is right in this area right here. So therefore it goes from -2 to 0. It's going to include -2, but not include 0. So we would just write I would use interval notation. To me it's much easier than using the set builder. So we would have it including -2 because there's a closed dot there. And it's going to go to 0. But since there's an open dot on 0, we have the parentheses. Okay. Any questions on that? Or anything from the homework last night? All right, so then we're going to start looking at absolute value today. So today is the 6th, I believe. Yep. So you want to put today's date. Our title is absolute value. All right, so I know you guys have all seen absolute value before. We'll dig in a little bit deeper. Again, you'll see that college algebra is a lot of things that you've known already, of things you've learned in Algebra 2, possibly pre-calc, and we just dig a little deeper into it. Okay. So first off, absolute value. Remember, it's denoted with those vertical bars. Okay, when we see those vertical bars around a number or letter, it's the absolute value. And the definition is the distance from 0 to A. In this case, it's A. If it was a number with the absolute value of 5, it would be the distance from 0 to 5 on a number line. So it's the distance from 0 to whatever's in those absolute value bars on a number line. It's always non-negative, okay? Meaning if it's a 0, we can't say it's always positive because 0 is not positive or negative. So if it's absolute value 0, that gives you 0. Absolute value of any other number is going to be positive. And again, the reason that is happening is because it's the distance from 0. I don't care if I'm going 3 blocks to the right or 3 blocks to the left, I still move 3 blocks. Right? So some examples, absolute value of -3 is 3. Notice this is non-zero. It's positive. Absolute value of 5 is also 5. It's positive. And the absolute value of 0 is 0. Okay, so that's not positive, but it's not 0. It's non-negative. All right, the other thing that we're going to have important that is kind of, this is like the new part. I'd say this old stuff was older stuff. This is the newer part. Okay, so when we have the absolute value of x, if the absolute value of x is equal to x if x is greater than or equal to 0, and it's equal to negative x if the x is less than 0. And we'll talk about what that's going to look like or mean in a moment. So this is checkpoint 6. It's on page 10. And it says rewrite each expression without absolute value. And of course you can't use your calculator. Okay? So what we're going to do is we're going to treat this if this whole thing was x. Okay? If what's inside there was positive, we're just going to do what it says. If what's inside here is negative, we're going to put a negative in front of the whole thing. Okay? So if we're not using a calculator, and we have 1 minus the square root of 2. Now, you might not know exactly what the square root of 2 is off your head, but is the square root of 2 going to be larger than 1?
No. Oh,
yeah, because the square root of 1 is 1, right? So something larger than 1, square root of 2, is going to be a little bit larger than 1. So when I do 1 minus something that's a little bit larger than 1, are we going to get a positive number or a negative number out from there? A negative. So this is going to give us a negative number. So therefore, what we do here is we put negative in front. We don't have to use the absolute values anymore, and we just rewrite what we had before. We then can distribute this negative sign through, and that would become positive square root of 2 and minus 1. And again, since we're not using calculators, that's what that absolute value would be equivalent to. Again, this is still a positive number in the end, because the square root of 2 is something larger than 1, and we're subtracting 1 from it. It's still positive, but that's a way of figuring it out, again, without using a calculator, just using our mathematical ideas. All right, part B is the absolute value of pi minus 3. So again, pi is about 3.14. If we subtract 3 from it, is that going to give us a positive number or a negative number? Positive number. So therefore, since what's inside here, this x is going to be larger than 1, or sorry, larger than or equal to 0, we're just going to say, all right, this is the same thing as it was. It's not changing. It's just pi minus 3. Because again, our x is, we're considering this whole thing like our x. Since this thing is greater than or equal to 0, our answer is just x, which is that whole thing, pi minus 3. The last one, it says the absolute value of x divided by x, and it says it's telling us x is greater than 0. So if this is greater than 0, the absolute value of x is greater than 0, we're just getting an x on top. Again, this is something greater than 0. There's not an absolute value on it though, so it's just x. So we have x over x, and what's x over x equal to? Just 1. So this is equal to 1. So you're just kind of using your mathematical knowledge to figure if what's inside there is positive or negative. If it is positive, you leave it the same thing and just rewrite what's inside. If what's inside here is negative, you put the whole thing in parentheses, put a negative in front, and then distribute that negative sign through. All right, there's a couple properties of absolute values that we're also going to need to know. So, title is Properties of Absolute Value. So our first property is that the absolute value of A is always greater than or equal to 0, which is what we talked about on the previous page. You take the absolute value of a number, it can equal 0 or it can be anything positive. So greater than or equal to 0 is what you get. The absolute value of any negative number would be the same as the absolute value of that same number but positive. So for example, the absolute value of -7 is the same thing as the absolute value of +7. They both equal 7. If you have a number that is not an absolute value, it's always less than or equal to the absolute value of that number. So for example, if I had -3, -3 is less than or equal to the absolute value of -3. Because the absolute value of -3 is 3. So -3 is less than or equal to 3. If I had +3 and +3, it would be the equal to part. If you are multiplying two things inside absolute values, you can break it apart. So that could be the same as the absolute value of A times the absolute value of B. Same thing with division. If I'm dividing the absolute value of A divided by B, that is equal to the absolute value of A divided by the absolute value of B. And the last one is called the triangle inequality. Which tells us that if I have the absolute value of A plus B, that does not equal absolute value of A plus absolute value of B, okay? It would be less than or equal to the absolute value of A plus the absolute value of B. It could equal it, but most times it won't. It would be less than or equal to the sum of each individual one. So only when they're multiplied or divided do they actually equal. All right, we got two last things and then you have some time to work. All right, the distance between 2 points. When they're giving you two x values, okay, you're just going to subtract those. So the points are A and B. You can do A minus B and take the absolute value of that. Or you could do the absolute value of B minus A. They're going to be the same thing. So check point 7, you probably want to write the directions to this one. I would just say distance between 4 and 5. Okay, if you want to shorten it up. Distance between -4 and 5. So if we're just talking about two numbers on the number line, as we're saying here, we just have to subtract them. And it doesn't matter the order in which we subtract them, as long as we take the absolute value of that whole thing in the end. Okay? So I can do the absolute value of -4 minus 5, or I could also do the other way around. I could do the absolute value of 5 minus, but again, be sure you're subtracting -4. So here, I would get -9 inside the absolute value, and the absolute value of -9 is 9. So the distance between -4 and 5 is 9. You think about that. To get from -4 to 0 is 4. From 0 to 5 is 5 more, so we're at 9. Here we have a double negative, so we are adding. And you get the absolute value of +9, which again is 9. So when we're finding the distance between two x values, subtract them, and just make sure you're taking the absolute value of that. All right, and then the last thing we're going to be looking at is some evaluating. All right, so we're evaluating this expression here. We're going to do 61, 63, 65. So you can, your directions, you can write evaluate x equals 2. And then we have the first one. Oh, sorry, x equals 2, y equals -5 also. Okay. So the first one is the absolute value of x plus y. Notice absolute value is a grouping symbol. So when I do absolute value of x plus y, 2 goes in for x, -5 goes in for y. And so this would be the same as 2 minus 5, which is the absolute value of -3. And we know the absolute value of -3 is 3. I'll do 63 down here for or over here. 63 is the absolute value of x plus the absolute value of y. So the absolute value of x is 2. X is 2. Absolute value of 2 plus the absolute value of -5. So we get 2 plus 5, which is 7. And notice that triangle inequality that we wrote on this last page. We said that when they're added together inside absolute value, it would be less than or equal to when they're added individually. When we add them together underneath 1, it was 3. When we add them individually, it was 7. So 3 is less than or equal to 7, like we expected. Okay, so that just goes to show that that works. And then 65, we're putting -5 for our y over the absolute value of -5. And so we get -5 over 5, which would equal -1. Okay, so here's what you're doing the rest of the period. Page 17, it's 51, 53, 55, 62, 64, 70, 71. And then you're going to take notes on pages 36, 37. If you need to get 36 and 37, you can take pictures of those. There's going to be a quick notes quiz on Monday. So what do I mean by a notes quiz? A notes quiz is if you took the notes on those pages, you're looking for bold words, you're looking for what's inside those yellow boxes. The notes quiz is basically just saying some questions could be true or false. It could be like true or false. Blah blah is when you do this. Okay, so if you took a notes, you would look at your notes for the definition of that and just write true or false. Or there might be an example almost exactly that was in the notes. Okay, so if you took a notes, you would have a quick answer. The notes quiz isn't meant to be like 20 minutes. It's meant to be like 5 minutes. Because if you took good notes, you should be able to answer it really quickly. It's a half sheet of paper. I think it's 5 or 6 questions. There's a couple true, false, and there's a couple that just directly come off definitions that are in the notes. Okay, so it's meant to be really should be a good grade, as long as you took the notes. Okay. So again, you're working on page 17, these numbers, and then taking notes on pages 36, 37.